Hello everyone. We'll just wait for another couple of minutes and start off as everyone joins. We'll start exactly at 5:10. In case you have please ask your friends also to join the meeting if they have registered. Okay, let's start with the workshop today. Before that, yeah. Can you all see my screen clearly? You guys are free
Yes,
to
ma'am.
yeah,
Yes,
don't call me
ma'am. Yes,
ma'am.
ma'am.
Yeah. uh yeah, so let's start. If you guys have any doubts, anything, you are free to stop me in between and ask it. And if you're not able to catch us also, like anywhere, you can stop, you can unmute yourself and talk to us. First of all, yeah, everyone, good evening to everyone, and I would like to welcome you all for today's workshop, that is Electroduction, a gateway to practical electronics. So when we release the form and when we asked what do you guys expect from the workshop, first of all, it's a basic workshop that we wanted to introduce most of you to what electronics is, because there are a lot of you guys who are from biology and computer background. So you and you might have got admission into electronics department, so you guys are like quite unsure if you have to go with core or if it is IT or something. So when we asked for what do you expect, a few of you, that's what you guys were like, we don't know with what we have to go ahead with. So I hope after the end of this workshop, to some extent, you guys are like, you okay, maybe electronics could be, we can give electronics a try, we can go towards core. So I hope this workshop will help you guys with that. So this workshop is like complete basics. We want you to understand what electronics is, like yeah, what exactly electronics is. Like most of you might think electronics is tough, and that's why you end up going towards IT. So we just hope, no, it's not like that. When you start off, maybe you'll here and there you'll find it a little difficult, but eventually you guys will start loving the subject, because electronics is really like that. So this whole thing, so as engineers, what do? We build projects, we build, you know, we yeah, as engineers we build projects. We That's what is our final thing. But how do you build a project? Like, how exactly is that thing? So first of all, you get an idea. It's either idea, it doesn't just make sense. If you have an idea in your head or in paper, you should bring it into reality, right? But before coming to the final stage, like before bringing the whole thing into reality, obviously you will not, in one go you will not reach your final product. You'll have to give it a lot of try. Maybe here and there you'll go wrong, so you'll learn from those mistakes. So before reaching the final project, there is something you have to make a prototype of that. Like you have to, you know you'll just not reach your final project. Like you have, there are previous stages, like where you try making the product. They're like, it's different versions. So that's the idea of a project. Like you get an idea, it's either in your head or paper, then you try bringing it into reality. That is what we do. And then when finally we are perfect, okay, we have finally got what we wanted, then we go with our final project, and we get the product. So yeah, so why learn electronics prototyping? Why should you learn? First of all, what is prototyping? So as I told you, you have an idea in your head or on paper. It just doesn't end there. If you have it there, it's over, it's only over there. But that's not the end. You have to go ahead of that. So that is prototyping. So basically, whatever you have in your head or on paper, you bring it into reality. But before coming to the final stage, you just make different versions of it. So that is prototyping. You try, making different, like, you learn, like, before coming to the final end product, you make different versions of it, where at times you might have everything working in there, but there is something still missing in your product. So you learn in that step. That is prototyping. So basically, giving your idea, which is a real shape, is prototyping. And prototype is that the before version of your final product. Why should you learn electronics prototyping? Why should you do prototyping? See, you can't simply have an idea in head, make a product, and just sell it like that. Who knows if it's working properly or no, right? So you should so you should make, like, that's why you should learn prototyping. Like before reaching your final product, you should know, like, where and all you can where and all you can go wrong with your product. So through this prototyping, you will learn. It's like, you will learn where you can go wrong, and you will correct that mistake. So when you finally reach your final product, you have it all ready, and there is like minimum possible error in your final product. And that's why it's very important to know what prototyping is, and why is it so important in electronics prototyping. See, basic in civil engineering, or in mechanical engineering, when you make a product or something, like in civil engineering, when you build something, when you're about to build something, you can just see the outside structure, and you might understand, okay, there is something wrong here, I have to change it. But in electronics, it's not like that. It's the inside of the circuit. You're just seeing it. You'll not be clear, okay, if there is some mistake in there or no. So that's why through prototyping, you'll know, okay, here maybe this is a possible mistake here, I can correct it this way, that way. So that is why it's very important to learn electronics prototyping. And it just doesn't come in 1 day or 2 day. It'll need you to try a lot of circuits, over the period. So this is just one example of prototype, of a prototype and the final product. Of course, every when you look around yourself, there are a lot of electronic stuff, so everything has a prototype. This is just one simple example, like it's a calculator. Before you have the final calculator in your hand, this is what a prototype would look like. So now, scope of electronics, like, see, it's very it is pretty sure that most of you like thinking, okay, now, uh, even though you are in EC or triple E branch, you guys might be thinking, okay, I'll go towards IT has a lot of scope and all of that. But true, IT really has a lot of scope, and there's, you can't deny it. But frankly speaking, in this decade, 2020 to 2030, electronics has also got a lot and lot of scope. That is because, why I'm telling you this, because the government has announced that they will be funding few semiconductor factories here in India, and many companies have come ahead to set up semiconductor fabrication factories in India. And which I think, which opens up a lot and lot of which opens a lot of which opens like so many doors for all us, for all the electronic engineers. And that way, the year by year, the scope for electronics is increasing. One reason, of course, there are many semiconductor factories, fabrication centers that will be coming up in India, now that the government has also told yes, even they will be funding it. And other than that, have seen in the if you guys have seen, there is a lot of development in the electric vehicle industry. Like, you see, they say in in other few 10 15 years, all the renewable sources, I mean, all these petrol, diesel, all these will reduce. Reduce, and then of course you can't depend completely on diesel or petrol vehicles. You will need electric vehicles. So EV industry has a lot of scope in the near future. And if you guys haven't heard about, BMTC have just launched e-buses in Bangalore. They have launched it in Kangeri. So you see, now the world is shifting. Like, I mean, wouldn't be shifting. Maybe just that there is so much so much doors opening up for electronic engineers. So if you think there is nothing for us, no electronic, there's nothing for electronics engineers, I'll have to tell you guys, you are thinking it wrong. Because in the next few years, you guys have a lot of opportunities that you it'll be coming to you. Yeah. Now, just having so many opportunities in front of you doesn't is just not enough, right? uh, there are certain things that as an engineer you should have. Okay, one reason why people go towards IT, maybe because there are a lot of opportunities, and the other reason why people go towards IT is maybe because they think the core subjects are just difficult. You can't handle it or something like that. No, but actually that is not true. It might be difficult when you're starting it, when it is like because anything that is new has its own challenges. So when you're just starting it, it might be really difficult for you. But as you understand the subject and as you go ahead, it's like a very easy subject. Electronics is basically like a story. You just have to understand the components, their behavior, their working. You understand that, you're an amazing electronics engineer, and you should know how you apply what you have studied in electronics. That is one important thing. So this in particular for an electronics engineer, or for a engineer who wants to take up core. The other general stuff, of course, you should have good communication skills. Like, if you whatever you have in your head, if you're not able to communicate, what is the use? If you're not able to communicate to your clients or to the people who's listening to you, right? So you should have good communication skills. Planning and organization of now, if you have any idea in your head and you do not know how to plan and organize it, there's no point again. So you should be good at planning it, and how you set up everything for your project. You should have you should be good in analyzing things, and you should be good at solving problems. Like, see, of course, when you go on any road, you'll face a lot of problems, so you should be capable of solving those problems, and you should be very creative in your thinking. You just can't be like, have the same idea every time and run it every time. That's not possible. The world demands a change, and you should give the change through your creative thinking. You should have good yeah you should have good information of the technology that is around you. Every day there's a new technology coming up, and you should have good information about that. The industry will want you to adapt to itself. The industry won't adapt to you. You should adapt to the industry, and you should be flexible enough as well. It can the world can demand anything from you when you are outside in that out there. So you should be flexible. You should be like a water. Like, you should just, whichever flask you're put in, you should just take the shape of over there. And you should have good relevant industry knowledge. Like, you should know what's happening in the industry, and you should pay attention to every single detail that is around you. So all these qualities, you're not just born with it, but you develop it as you grow. So you should just be aware of all these things. Yeah. So what is the best way to learn, guys? It is to do. Like, unless you don't start off, you will not know what to do. Okay, and now we'll have Srinidhi. He'll take you ahead with the presentation. Srinidhi.
Yes, Ruchita. Thank you. Let me just share my screen. Cool. So yeah, good evening, everyone. I hope my screen is visible. Is my screen visible? Hello.
Yes, Srinidhi.
Yeah. Okay. Thank you. So yeah, like Ruchita said, what's the best way to learn? The best way to learn is to do, right? Because electronics is one subject, where you can find its application in your everyday lives, right? Everything around you is electronics. So the best way to learn is by start doing it. So you need to start building a lot of projects in order to learn more things. But where do you actually start, right? Now, what makes an electronics project? Every electronics project that you see either on Google or YouTube has a definite structure. Okay, every project has those basic components that makes a project a whole. Now, in order to understand what exactly makes an electronics project, it's important to know this concept called embedded system. Now, maybe you might have come across this word embedded system. If you just go to Google and search the highest paying jobs in the electronic sector, maybe you would see this word embedded system. So what is this embedded system? Now, embedded systems are the computer systems that can perform a specific set of instructions. Now, the best example to explain this is everyone have washing machine in your home, right? Most of you do. So basically, the washing machine is a best example of an embedded system. So basically, it is a computer system in the sense it has all the things that a computer basically has. I'll just explain to you in the next couple of slides. Now, it is a computer-based system that do not actually look like a computer, but can perform a specific set of instructions. In the sense, those are the systems that has been built purposely to perform a specific task. For example, if you are just confused, okay, let me just tell you this. Now, your computer or laptop is a general purpose machine, right? It can just do anything. Like, you can open games, and it's basically a general purpose device. But you can't do multiple stuffs on your washing machine, right? That will sound very vague, because washing machine is designed and built only to perform a specific set of instructions. So that is basically an embedded system. Now, why is it called embedded? Because the complexity is embedded within the system. I mean, if this sounds confusing, let me just make it simpler. Basically, the word embedded means if something is attached to another thing. Now, what happens in an embedded system is the hardware and software and the other required peripherals are actually attached permanently to perform a specific instruction or a task. Now, you guys have even heard of this word Internet of Things, right? So, simplest definition of IoT is that an embedded system that has an internet connectivity is called as IoT system. Okay, it's as simple as that. Now, okay, what is this Apollo guidance system? So basically, the concept of computers and embedded systems that actually originated during the late 1950s and 60s. Now, well, Apollo guidance computer, this is the system that actually landed the man on moon. So basically, this was the first real-time modern embedded computing system that was built. It was built by Dr. Charles Draper at the MIT. You guys have seen this meme, right? That people today are craving for 16 GB of RAM, even if they have 8 GB RAM. But this is the system that actually landed people on moon with only 4 kilobytes of RAM, 4 KB. Yes, so this is the system. So yes, this was the first real-time embedded system that was actually built. This was just an interesting fact. Now, what are some of the commonly built projects? Now, if you just go to Google and search, easy best projects for EC engineers, best projects for final year students. Now, here are the most commonly built projects that you would come across, right? Uh, Bluetooth controlled car, fire alarm, automatic hand sanitizer dispenser. Well, this is a trending project that you might have seen across Instagram reels and YouTube videos. Now, and also the line following or obstacle avoidance car. Now, all these projects that you're seeing on the screen comes under the category of embedded systems. Now, let's see what actually makes an embedded system. Well, here on the screen, you're seeing a block diagram. Now, all these projects, we can actually break all these projects into a block diagram like this. Now, let me just explain that to you. Now, basically, an embedded system consists of an input unit, an output unit, and a control unit. Well, these three are the most important thing in any embedded system. The control unit usually it has a microcontroller. It is like a mini version of a microprocessor that you will see in your laptop. Well, what a microcontroller does is it is like the brain of the embedded system. Okay, it is responsible for all the arithmetic logic operations and whatever that goes inside the computations. So basically, in embedded system, the foremost important thing is the input unit, right? For example, if you take your washing machine, the washing machine tells, right, how much how much water that needs to be, how much water you need to add. So how does it tell? It tells it because it has a sensor that actually tells the weight of the load that you have put inside the washing machine. Now, some of the most common input units that you would find in any embedded system are so basically a sensor. That's the most widely used and most important things in electronics. Okay, sensor. And also you have switch and you have keypad also. And some of the most common output devices in an embedded systems are motor. I mean, if you take an example of a Bluetooth controlled car or an obstacle avoidance car, the output unit is a motor. And also you have display and solenoid. Well, solenoid is basically a coil. Okay, no, don't worry much about that. It's basically an electromechanical device. Okay, it's actually used in washing machines. So yeah, if you take let's say okay guys, let me ask you one question. Let's say fire alarm. Okay, let's just take this example of fire alarm. Can you guys tell me what is the input unit in a fire alarm? Anyone?
Red light.
Sorry.
Red light sensor.
Smoke.
Yes, yes. Yes, you're right, but that's yes, that's also true, but that's more of an industrial application. At a very basic level, like when someone else said smoke. Yes. So yes, actually both are correct. So basically, in fire alarm, you would either use a fire detector or you can even use a smoke detector. That's like that detects the effect of fire. Okay, you don't, if you can't directly sense the fire, you can at least sense the effect. Okay, that's one of the engineering skill you need to learn. So you can either use a smoke detector or you can use a direct or you can use you can even use things like heat sensor. Okay, yeah, that's just one example. Now, yeah, all these projects we can actually one by one we can go and divide it into the block diagrams. Uh, now, now let's just talk about this serial and wireless communication. Now, if you take an example of a washing machine, like I just said, It does not have any form of a wireless communication, right? Because you don't need to control the washing machine. Well, if you take an example of a smart washing machine or whatever, then that's a different case. But the normal washing machine that you would find in everyday house does not have any form of wireless communication, in the sense you can't control it by using your smartphone or something, right? You just need to go there and press button. Now let's just see an example of a system that has a wireless communication. Now, a best example of a system that has communication is your radio controlled car or remote controlled car, whatever you call. So an RC car, this is how a block diagram of an RC car system looks like. So basically, you have push buttons, or you can even have the what do you call it as an XY controller. Okay, so basically, those you can use even a push button for that matter. So basically, yeah, the buttons are the input and the motors are the output. But what do you see in between? Well, the microcontroller and the control unit hasn't seen in this block diagram. Okay, just to make the diagram look simpler. Now you see here that there's RF transmitter and the receiver, right? So this is basically the serial and the wireless communication uh, unit in a system. So this encoder and decoder, don't worry much about it. So basically, it exists because the encoder, actually what it does is it converts your digital signals into readable radio frequency signals. So wherever you use RF transmitter receiver, you always have encoder decoder. Okay, wherever it goes, it's just like Romeo and Juliet. Okay, so wherever one goes, the other comes along. So now, what are the things that every beginner electronics enthusiast must have? Now, you guys saw a list of projects, right? Now, how to actually start building these projects? Now, you might have seen in the YouTube videos, right? Well, if that person is building a project, you can see in his background, right? There'll be a shack, where the lot of electronic components will be arranged. But you don't need to buy all of that. Well, here on the screen, whatever you see is are the most basic elements that you need to have in your house if you want to start building electronics project. Now, why? Let me just tell you. Can anyone guess what is the first thing over here?
Breadboard.
Yes, true. Good. So the first thing is actually a breadboard. Why? No, don't tell me because it looks like a bread. No. There's a different story behind it. I would suggest you guys to go over the internet and learn more about it. Now, what this breadboard is basically, now let's say if you are building some electronics project, let's say if you are building some, you're putting some LEDs and doing some stuff. So you need a platform where you can put all those stuffs, right? You can't just randomly connect wires or something like that. That would mess up. So breadboard is basically a platform where you can place all the electronic components and arrange it accordingly so that it will become convenient for you to start prototyping. Now, about breadboards on how it works, we'll just learn in the further slides. Now, let's just go to the next component. Now, the next what you see here is a multimeter. Now, if few of you guys, if you have taken PCME in your second PU, might have very well known about this, or even some of you may have learned it in your 10th as well. So basically, guys, electronics is all about voltage and current, okay, and also resistance for that matter. So at every stage in your electronics project, okay, at every stage you need to be constantly aware of the voltage and current. So that is the reason you always need to have a multimeter. Now let's say if you build something and okay, it's not working, what do you need to do? You just take a multimeter and measure the voltage and current and check if it's the desired value that you would expect. So that is the reason you need multimeter. That's the most basic and it's a must have device. Now next what you see is a resistor box. Oh, sorry. Okay, yeah. Uh, this is actually a resistor box. Now, the thing is, see, in electronics, there are so many components. We'll just talk about the components in the further slides. Now, the thing is, all of the components in electronics, okay, work on a specific voltage or a current rating, okay. So, if you have what you see over here is a 9-volt battery, okay. So, let's say if there is a device, let's say an LED, okay, I'm just giving an example. If there is an LED that has a maximum voltage rating, let's say it's 2.2 volts is the maximum rating. So what happens is that every device, okay, every practical electronic device has even a current rating, okay. That means that if more than the prescribed, sorry, not if more than the rated current passes through it, the device may get damaged, okay. So that is the reason you always need to have a resistor box, okay, because this is actually called an assorted resistor box, okay. uh, the next is the connecting wires. So over here, to be specific, these are called jumper wires. If you look at the wires, then you can easily make out that this is something that has been designed for breadboards. Okay. Now, if you look closely, you can see two ends. Okay. This wire is actually called as male to male wires. Okay. These are called jumper wires. So basically, you use this type of wires to connect the components on your breadboard. Now, the next we have, like I told, it's a 9-volt battery. Now, guys, all of the projects that you build, okay, most of the projects that you build requires, works on basically 9 volts or max to max 12 volts. Okay, well, 12 volts, okay, just forget it. Max to max, most of the components that you use requires either 5 volts or less than that. So basically, if you want to start building projects, having a 9-volt battery with you is always a must. Now, in future, like if you are ready to spend more, then you can even search about dusk power supply. So that is what you use in your labs, right? Where you can actually uh, uh, draw how much ever voltage you want. You can use that in future if you are building more projects and if you are ready to spend much money. Now, over next, what you see here is called as a general purpose PCB. Can anyone tell me what is PCB? You guys must
Printed
definitely
circuit
have heard.
board.
Yes, true. Good. So printed circuit board. Well, basically, if you go on Google and search PCB, you would actually see a different kind of diagram, right? Something will be connected. Well, this is actually called as a general purpose printed circuit board. Now, the reason it is called as general purpose printed circuit board is because you can actually take components and place it and use it. Okay. Now, how is it different from breadboard? Look, now if you are building a project, let's say if you are just connecting, okay, let's just take a simplest example that we'll be working out later. Okay, so let's say if you are connecting a group of LEDs and maybe doing a blinking circuit. Okay, so what you do first, you take all the LEDs, resistors, components, you connect it on the breadboard and see that if you are able to meet the functionality, if the circuit is correctly working or not. But let's say if you want to take this circuit, go out, show it to your friends, it becomes really difficult to take this breadboard, because see, this breadboard, how it works is, when you place a component, these pins, these holes have spring inside it. Okay, so if you just push it, the breadboard holds all the components, but you can't actually use it permanently. Okay, if even if you just push it using your index finger, the components comes out. So you don't want that to happen. So that is the reason you have this general purpose printed circuit board. So once you have built your circuit on a breadboard, you take all the components and place it on your printed circuit board. Now, what to do after you place all the components on your printed circuit board? Now you can see that this printed general purpose printed circuit board is nothing but a copper clad board with just properly arranged holes in it, right? So what you need to do is you need to take the components, you need to push it inside these holes, and what you need to do is you just need to solder the components. So that is what you see here. This is called as a soldering gun. Okay, these are all the basics. Okay, so many of you, I'm sure, have already know this stuff. Now, yes, in your general purpose PCB, you need to place the components, and on the back side, you just need to make a connection by soldering. Okay. Now, the last thing that you see here is called as wire stripper. Now, of course, now why it's used is, let's say if you have a wire, not this one. Let's say if you have a normal wire, okay. If you want to make connections, you will have to remove the insulation coating, right? Of course, we all do jugad, okay. We just use our teeth and pull out the insulation coating, but that doesn't look professional, okay. For that matter, even I don't like that personally. No, so that's why it's always suggested to take this wire stripper. Okay, it's really convenient. You can even you can also use it as a temporary scissor if you want. Now, sensors. Now, like I said in the above slides, in any embedded system, the input unit are the most important. Okay, so well, the most commonly used input unit in embedded systems are sensor. Okay, now a sensor is a device whose purpose is to detect events or changes in its environment like pressure, temperature, etc., and send the information in an electrical form. So here are the few of the commonly used sensors that you would see in your day-to-day lives. Okay, so yeah, okay, yeah, I'm sorry. So yes, these are just few sensors that you would find it in your day-to-day lives. Now, yes, this is a gas sensor. This is an ultrasonic sensor. Now, you guys have heard of motion sensor, right? So basically, motion sensor is a layman term. In actual technical term, it is actually a PIR sensor. Okay, PIR stands for passive infrared sensor. So about sensors, I would definitely recommend you guys to go over the internet and learn more things. And also, guys, one of the most important things while building projects is self-learning. Okay, you always shouldn't depend on one single source. So if you get a doubt in between, always feel you just need to have that enthusiasm to go out to Google and clear your doubts as soon as possible. Okay, so yeah, these are some kind of commonly used sensors. Now, is there any way that we can classify these sensors? Now, in electronics, the sensors, there are many types of classification, but the type of classification that you need to know while you're building projects are a classification based on the signal. Okay. Now, basically, these sensors, you can divide it into either digital sensors or analog sensors. Now, what are these analog and digital sensors and what's the difference? Now, if we take an example of a PIR sensor, okay, if we take an example of a motion sensor, so what it does, it just gives out signal, right? If there's a person standing or not. So if a human is detected, the signal level goes high. If there's no human, there's no signal. It's as simple as that. You either get a high or low signal, one or zero in binary. So that is a digital sensor. If you now let's see what's an analog sensor. Okay. Now if you let's say okay, let's say there's okay, not thermistor. Okay, let's say if you take a temperature sensor. Okay, now, a temperature sensor, what it does is uh, throughout the continuous time, continuously, it just outputs the signals corresponding to the temperature in that particular environment, right? So continuously, it will be telling, what's the temperature now? It's 21, 22, or 23. So, so you will have a lot of range of values, right? 21, 22 to the whatever the range that you have specifically set in your circuit. So basically, you will be getting a lot of range of values, and all those signals are continuous. Okay, there's no break in between like a digital sensor. So that is why it is called as analog sensor. So if you guys have studied electronics, then you would definitely know what is an analog signal and digital signal. So yeah, this is just an application. Now let's look at the output units in embedded system. Okay, so some of the commonly used are motors. Now, if you take an example of a remote control car or Bluetooth control car, or let's say a line following or obstacle avoiding robot. Now, motors are actually employed in all those projects. So not only that, if you want to make your system move, you use motors. As simple as that. Now let's look at what are some of the most commonly used motors in the electronics projects. Okay, look, there are lot of types of motors are there. Okay, now these are basically comes under the class of hobbyist motors. Okay, because apart from doing small projects, you can't do anything with these motors. Okay, so again, the entire thing behind is whatever you're doing is you are building a prototype, right? So you aren't directly employing it into commercial use. So that is the reason you use all these hobbies motor. So it can't run on maximum speed like this normal DC motor do, but mm, we can't do anything. That's a trade-off, but it's a necessary trade-off. The most important thing is to get the system moving, right? Now, next, we have servo motors. Now, basically, servo motor is just like a normal motor, but technically speaking, it's a motor with feedback. But in simple terms, basically, if you want to control the movement of the axle, in the sense, this is the if you want to control the movement of the motor, maybe you move it slowly to the right. Well, basically, let's say a robotic hand. Okay, basically, servo motors are the things that servo. You will find servo motor in robotic hand. Okay, because you need to move the hands in either anti-clockwise or clockwise simultaneously, right? That you can't do it using a normal motor. So that is why you use a servo motor. So now next comes the display devices. Now, in some of the projects, let's say if you are making a project to measure the temperature of a person. Okay, so in that in those projects you will need a display device, okay, that actually displays whatever the functionality you require. Now here are some of the commonly used display devices in do it yourself DIY projects. Now out of all this, the most simpler one is the LCD. So can anyone tell me what is the full form of LCD?
Liquid crystal display.
Yes, true. Yes, good. So basically, LCD is you would have seen while buying your television or something. The same technology is actually employed in this small components also. Basically, this is a 16 is to 2 LED. 16 is to 2 is just basically the matrix of pixels. Okay, don't worry much about that. Now, apart from that, you have this OLED. Okay, well, LED is light emitting diode. You all know. OLED is basically organic light emitting diode. Okay, basically, the difference between LCD and OLED is that you can display colorful images with a greater contrast using an OLED display. And the other types of display are TFT LCD. Well, TFT stands for thin film transistor. uh, well, basically, if you want let's say if you want to build a device that has a touch screen function, well, all these devices cannot take input on the screen, okay, but this TFT display can take input. So if you are using, let's say, okay, what example can I tell? Okay, let's say if you are making a okay, let's say if you are making a small car only that can be controlled. Now if you don't want to control it using push buttons, but if you want to find some more creative ways, then you can use this TFT display. You can program it and use it like a touch screen. You can just use it like a smartphone, okay. So this can act like a touchscreen monitor. Oh, sorry. So yeah. So next is this. So these are dot matrix and the graphical LCD. Well, these are kind of an outdated ones, but yes, just these are just make a note, okay. Just remember this. Now, yes, the one more type is 7 segment display. Okay, I mistakenly moved into next slide. You might have seen. So basically, in movies, etc., or if you actually find an old digital clock in your homes, if you just see it closely, you can find that you have this uh, thing where the numbers are displayed. So that those are basically 7 segment display. Okay. Well, this is just a funny example of where you can find a 7 segment display. Okay. In movies, in real, you can see this. Okay. Oh well, this actually reminded me. Okay, whenever you are carrying these electronic components, no, and especially when you are coming through metro, so be careful. Okay, they have caught me many times, and they had actually questioned me, what is this, what is that? So yes, if you are coming, make sure that you always have a college ID card with you. At least you can explain them that you are bringing this for lab. So yeah. Before moving to next slide, these are all the basic stuff that you actually had to know while building projects. Now let's just say if you now let's say if you are stuck in pandemic and you can't go buy all these components. Now is there any way to actually do it at home? Yes, there is a way. From here on, Ruchita will continue this presentation. Over to you, Ruchita. Thank you.
Yes, Srinidhi. Uh, is my screen visible?
Yes, it is.
Okay. Yeah. So yeah, Srinidhi just told now if we all now see it's a practical thing that's already happening. Now if we are stuck in something like this in a pandemic, or if we are not able to go out and get any component for our circuits, so what is the best way to make the circuit? It is online simulation. Like now almost everything's become online for everyone in their life. So even it's really important that you know how to make a physical circuit, as well as how to make a online version of your physical circuit, which is nothing but a which is simulation. uh, you know what, you can say the simulation is basically a prototype for a prototype itself. So if you are scared to start off, if you're scared like to make a circuit, that okay, if I make this, maybe I'll burn out things or something, you can maybe first try it online using any simulation software that is available, and then you can make the physical circuit. we are there are many free online simulation softwares that are available. These are just a very few of them, like Easy EDA, Autodesk Circuits, PathSim, Every Circuit Lab. These are like very few of them. So simulation, yeah, it's basically you're doing your circuit online. Yeah. uh, so here there are many circuits, many simulation softwares that are available which are free as well. Not everything is free, but there are a lot of free softwares that are available. You just have to find the one with which you are comfortable. Today in this workshop we'll be learning how to use Tinkercad. Now Tinkercad is free of charge online 3D modeling program that is available. So basically let's just see the software. It's very simple. You just have to go and just select Tinkercad. You have to select, you can select the first link. So basically it'll ask you to create a profile for yourself. Now because I already have a profile, I just got logged in directly. You have to create a profile for yourself. So here when you just log in, you'll find this page where you have 3D design, circuit, code blocks. So 3D design is basically for mech, circuits is for us electronics, and code blocks is for the computer science people. So you have all three. If you want to learn all three, you have all three here in this software. We'll select circuits, and then here basically you'll have the circuits that you have done so far, and then we'll just select create new circuit. So yeah, so this is how your Tinkercad window will look like. Tinkercad working window will look like. uh, Here you can just give a name. This is like you can give a name to your circuit. Now let's just give it as Electroduction. Yeah. Yeah. So yeah, so basically you can see this right side corner, right? Here you'll find all the components that you will require. Maybe not everything is present, but most of the components you'll find here. So everything that you will require, let's say, okay, let's say, yeah, you can select. So it's very simple. You just have to click it. You get the component here. Drag and drop it here. So yeah, now this is a resistor. Like, you can rotate the position of the resistor, like using this. So you can put it in the orientation that you wish to. And this is undo. Like if you have done some mistake, you can just undo and redo the stuff over here. And now yeah, you select it, and yeah. Now you can actually put a note around your component. Now using this, like if you want to put a note, like you have made a circuit and maybe someone else is viewing your circuit and you want them to know why you have used it or something, you can put a note. I'll just put that this is a resistor. So you can put anything that you want in the note. This is if you want to hide the note, you can just click this. If you want it to be visible, you can use this. Yeah. So that is the whole thing. Like you can find most of the component. Like say, okay, let's search for a breadboard. So you can find a breadboard here. Yeah. Sorry. Ah. So now let's go back here. So yeah, Srini already told you why we require boards. Boards, of course, are very important. You just can't make your circuit in the air. You can't connect here, everywhere. You need some platform. So physically, we make use of these boards. There is a general purpose PCB, spring board, and there is a breadboard. For now, in this workshop, our area of interest is a breadboard. Uh, Srini already told you what a PCB is, but let's just have a look at the springboard. Springboard is basically it's an outdated board actually. So basically you'll just have nails on the board, and there is spring around the nails. So if you have to connect anything in the springboard, you have to just push the spring down, if you can, it's not clear. You just have to push the spring down and put in the wires or components, and then just leave the spring. The connections are like quite easy in springboard, but this is quite outdated. For our area of interest is a breadboard. So of course most of you here will know what a breadboard is, but just in case for people who do not know, let's see what a breadboard is actually and how the connections are made inside. Like, yeah, how the connections. So basically, go back here. This is more clear. Now, so basically, this is how a breadboard look like. This is a small version of the breadboard. A bigger breadboard looks like this. It's one complete thing. This is just half of it. So here, can you see these vertical dots? So each vertical set, there's an internal connection. Like it is internally connected. Okay, you can see this here. Wait. See, each vertical set is internally connected, like throughout the breadboard. Throughout the breadboard, vertically, these five dots are internally connected. There is no connection internally. There is no connection between these two set of lines. All throughout the breadboard. Now, similarly, there are horizontal connections also. So you can see here, right? These from this end to this end, there is one. There it is horizontally internally connected. Again, there is a break here. There is no connection between this set and this set, and there is no connection between these two horizontal lines. So here it is vertically internally connected, and here it is horizontally internally connected. You can see it like this. Okay, that's how a breadboard is. Now here, let's try a series and parallel combination of a breadboard. Okay, let's just take two resistors. Now when you say a component is is connected in series, when it's like this. I'll show you, just a second. Okay, and this component, see, one end of this component is connected to the other end, but these two ends are not connected. They're connected to the other part of the circuit. So when there is a and you can notice, uh, that here it is connected on this single line, because this line is internally connected. When you make a connection like this, these two components are also connected now in series, right? So similarly, just giving you how a series and parallel connections are made. Now here, one end of this component is connected to this end, the other end is connected. So when you say a connection is made like this, it is parallelly connected. Again, see, this row is column is internally connected. So these two components are parallelly connected. Okay, so that is how connections are made inside a on a breadboard. Yeah, now let's move on. Some of the basic components that we as electronics students should have an idea are these. Now, in this workshop, we'll not use all the components, but we'll learn how to connect few of these components. Yeah, one resistor. Like resistor is like everywhere in your circuit. Resistor is like one of the most important component. So basically, you know that this is how a resistor looks like, and there are color bands on the resistor. These color bands actually indicate the value of the resistor. So this is there is something called B.B. Roy of Great Britain had a very good wife. This is a notation to keep in mind all these the color band, so that you know which value the resistor is. Okay, now guys, when you go on internet and when you search for some circuit or some project or something, the first thing that when you click on a link is that you get these components, the materials needed for your circuit. Now you see, so now say for a resistor, they particularly say, okay, this value of resistor is required, right? uh, how is it calculated? Now, okay, for example, here this 330 ohm resistor, why do you require this resistor? To which component is it connect? Like you require this resistor? Can anyone tell? Okay, so basically you will require it for an LED. For an LED. See, the LED is, when you pass too much current through it, it is not a, the LED is not a resistor. It will not limit the amount of current or that has to pass through it. It'll just take, if say if the maximum current it can take is 20 milliampere. If you send 40, it will take 40. And what happens if it takes 40? It'll burn. It'll The LED is gone. There's no use of it. So that's why we make use of a resistor. Of course, it is used in many other places. This is just a simple example that we are giving you. So the resistor is used along with the LED, so that we limit the current that is coming to the LED, and we do not burn the LED up. Now let's just say there are different LEDs that are available in market, like the one that gives out white light, blue light, red light, and each of this has a value of has a voltage value that it can take, right? Now say the supply voltage is 9 volts, and for example, let's take the white LED, and the supply voltage is 9 volts, and the white LED can have a voltage of 2.2. And let's say, see, in the previous slide we say the forward current through an LED is 10 milliampere to 30. Let's just take the average of it, let's say 20 milliampere. We'll just substitute this. Now say there is we'll just use this formula. Vs is nothing but the supply voltage. Here we'll be giving a 9-volt supply voltage, and the voltage through the LED, the forward voltage is 2.2, and the current will take it as 20 milli. So when you solve this equation, so the value of the resistor that you require is 340 ohms. You always do not take the exact value of the resistor, maybe a little higher value, and yeah, maybe a little higher value. Okay. So now let's try making a connection, LED and the resistor connection. Okay, so basically let's take an LED. Okay, we already have a resistor. So this resistor, see, when you click on the resistor, you get a box here. This box, you can name the resistor anything that you want, and here you can put the value of the resistor, and this is, you can select in which range you want it. So we do not want it in kilo ohms, we just want it in ohms, and we had 340, but let's just take a little higher value, say 400 ohms. Okay, so this is the 400. See, when you change the value here, the color code on the resistor also changes. So each color code has a value. Yeah, let's take an LED now. Okay, there's an LED. So see, a resistor does not have any particular leg. You can make the connections in any way, but a LED, it has a positive and a negative leg. So okay, anode is a positive leg and the cathode is the negative leg. So we just make a connection here, and then when you click on this, you can change the color of the LED. So we just calculated for white. So let's just select white, and then let's take a battery. We have it here. Yeah, so you can just keep it here. So how you make the connection of wires is you can just drag it and make a connection. See, usually in breadboard you see this top lines plus and minus. These two, the horizontal lines, basically they are for convention we use them for ground and power supply. It's not it's not a compulsory thing that you have to use it for this, but it's just for convenience that you use the line. Now see, you can change the color also of the wire. Now say for black, for negative we take black, and for positive we take red. So now when you connect here, this entire line is grounded and this entire line is given the power supply, right? Yeah. So now we'll make a connection. So this, see, the positive end of the LED should be connected to the positive end. Yeah. and the negative, and then we'll change the color black. Negative end should be connect. The negative end should be connected to the negative end. Now see, there is a complete connection. Like the positive end of the LED is connected to the resistor, and the other end of the resistor is connected to the positive of battery, and then comes the negative of battery, and then that goes. So it complete. You should always make sure your circuit is complete. Like after you may so in Tinkercad, after you are done with the circuit, you can just say start simulation, right? Yeah. See, the LED is glowing, which means your circuit is correct. Yeah. This is just a small circuit demonstration, that's it. And then let's go to the next. So yeah, at times, the resistors are basically fixed values. See, in simulation you can get any value of the resistor that you want. You just have to type it, you just have to type in the box the value of the resistor you require, and you get it. But physically, when you do a circuit, it is not possible. The resistors, they come with some standard values. So in that case, when you want an intermediate value, when you want a value somewhere between the standard values, you can use a potentiometer. So what is a potentiometer? A potentiometer is basically a variable resistor that is available. So this is how a potentiometer looks like. Okay. A potentiometer, it has three three leads for connection. Excuse. So basically you can make connections either between, excuse me, you can make connections either between lid 1 and 2, or 2 and 3, or 1 and 3. Now how do you, okay, let me make can you see this functional diagram over here? So when you make connection between the lids 1 and 2, from this end to this end is the value of the resistance that you will get. So basically the potentiometer comes like a 10 kilo ohm potentiometer. So you can range it from 0 to 10 kilo ohm to whichever value of resistance you want. Or it comes, you say you get 100 kilo ohm potentiometer, like that. So you get different values of potentiometer. So when you make connection between 1 and 2, the resistance can be varied between these two. So when you rotate, there is this dial you get here. So when you rotate this dial, this wiper also rotates. Yeah. So when you rotate in the clockwise direction, when you make, if the connection is between 1 and 2, as you rotate in clockwise direction, the value of resistance also increases. Say here it was say 4 kilo ohms. So when you rotate this dial, this in the clockwise direction, it increases. So as the dial reaches here, the value becomes 10 kilo ohms. Similarly, you can also make connection between 2 and 3. So when you make when you make connection between 2 and 3, this is the value of the resistance of the potentiometer. Here you say if it was 4 kilo ohm back then when you made connection here, when you make here, and if the dial is here, the wiper is here, the resistance of the pot would be 6 kilo ohm then. So when you rotate the wiper in clockwise direction, uh, the value of the resistance decreases. Can you see the difference? Like here, as you rotate in clockwise direction, the value of the resistance increases. Here, when the connection is between 2 and 3, and when you rotate in clockwise direction, the value of the resistance decreases. Now you can also make connection between 1 and 3. So when you make connection between 1 and 3, it is the entire thing that is used. So it is just used as a fixed resistor. If it's a 10 kilo ohm pot, it will be used as a 10 kilo ohm potentiometer. Potentiometer is also known as a pot. Okay, now let's try using this in the circuit. Okay, here. Yeah, there is always make sure you connect a resistor with the LED, even if we are using, now we'll use a pot, right? There's a potentiometer. So this is a potentiometer here. I'll just keep it here and rotate it. Yeah, we'll just keep it here. We'll delete this wire. Now see, one end you can just connect from here. Yeah, you can just make a connection one end over here, and this is terminal 1 and this is terminal 2. this is the wiper thing. So from here, let's make a connection to here. Yeah. Now let's try simulating it. Okay. See, now as you move it in the clockwise direction, you see the LED is not glowing. Why is it not glowing? Because the resistance here is increasing, right? So as you, yeah, it is increasing. Now let's just move this connection here. Oh yeah. Uh, just a second. See, we can also change the pot value. Here, 250 kilo ohm is like very high resistance value for a resistor. Let's just make it 1 kilo ohm, which is more than enough for a pot. Okay, yeah. Now let's simulate it. See, when you rotate it in the clockwise direction, as you go, the LED becomes dim as you rotate in the clockwise direction. Why it becomes dim? That is because the value of the resistance is increasing as you move. Now we can make the connection other way around also. Okay, from here to here, you make a connection, and now we simulate. Oh wait, just a second. That was wrong. Yeah, yeah, here. Now, yeah, this connection. Now, when we simulate, see, as you move increase in the clockwise direction, now the LED is becoming bright. In the previous one, when we are rotating in clockwise direction, the LED was becoming dim because the resistance was increasing. Here, it's the ulta. The LED is glowing up because the resistor is decreasing. So that is how a potentiometer is used. Yeah, did you guys understand? Yeah, so that is about a potentiometer. Okay, now from here, Srinidhi will take you ahead. I hope you guys understood till now with whatever we did. Even though it was like very simple, it is the basics. Like it just will start off for you to construct circuits. Now Srinidhi will take you ahead. Srinidhi?
Yes. Hello. Am I audible? Hello.
Yes.
Okay. Yeah. So yeah, is my screen visible?
Yes.
Okay. So guys, till now, you guys learned about resistors, LEDs. Now let's just see what are the some common types of switches that you can use it in your projects. Now, well, there are a lot of types of switches, but here are the most commonly used kinds of switches. Now, the first one is the slide switch. I think this one you might have seen it in many places, right? We just need to, slide it sideways, and the switch will either open or close. Now, the next kind is the power switch. I think this one is you'll be really familiar if you are using this, extension cords and places. This kinds of switches will be used. Now, one more kind of switch that's actually an interesting one is a push button. Now, you guys, everybody uses earphones here, right? Now, in your earphones, you will be having a button, right? So that's a push button actually. So basically, push button usually has four legs. Okay, we'll be studying about push buttons in detail in the next few slides. Now, so yeah, apart from and compared to all these switches, push buttons are the most interesting kinds of switches. Technically speaking, the push button actually comes under the category of tactical switches because if you see the other kinds of switches, if you just like let's say if you just switch on, then you can just leave it; it'll be on, right? But not the push button. It's a two-state and a tactical device. You need to push it, so it will be either on, or if you just release it, it will be off. So it's that kind. Now we'll be studying about push buttons in a more informative way. Now, push buttons, if you see, it has four legs. Okay, if you just look in the picture, two legs are will face one side, and the other two legs will face the other side. So basically, naturally, okay, when you haven't pressed the button, okay, when you haven't pressed the button, that is when the button is released, the two adjacent legs, that is the legs that are not facing towards each other, are internally connected. Now, I'll just tell you, in the demonstration how exactly we are making use of this feature. Now, what happens when you press the button? Whenever you press the button, the two legs that were facing one side gets connected. Okay, so that means that let's say I'll just show it with the LED circuit that Ruchita showed now. So basically, you will be connecting this push buttons in series. Okay, these two legs right here, you will be connecting in series. Okay, so that you can either open or close the circuit whenever you press. Okay, let me just show you the demonstration. I'll just go to Tinkercad again. I'll just click on new circuit. Okay, so I'll just let me just show the working of a push button with the previous example that Ruchita showed. I'll just take a breadboard and an LED. See, one of the reasons that we are demonstrating using Tinkercad is because if you look at the other softwares, right, the other softwares that we mentioned, so basically all those softwares you'll be using schematics, okay, in the sense you'll be using actual circuit diagrams. Maybe for a beginner it might confuse you. So that is the reason we are using Tinkercad, because this is how exactly the components looks like in real life, right? So it will be easier to build circuits. So I'll just connect a resistor in series. And just to click on the resistor to change its value. I'll just keep it 400 ohm. You can see the push button here. Okay, just a second. I'll just connect battery. So guys, like Ruchita said, whenever you're connecting the battery to the breadboard, it is always advised to connect it in the vertical section. Okay, so that the entire column will be powered, and wherever it is required, you can draw in power easily. So okay, so next I'll just drag this push button. Okay, yeah, I'll just keep this. I'll just keep it here. So let me just connect this. So yeah, like I said, the push button, just like a switch, we'll be connecting it in series. So yeah, from one end of the resistor. Now, guys, if you look closely here, uh, two of the legs are facing one side, right? And the other pair is actually facing the opposite side. So naturally, when the button is released, okay, so these, okay, it's even named, okay, for our convenience. Now, let's say the terminal, are you able to see the uh, numbers, terminal 1B and terminal 2B? So naturally, just a second. Okay, yeah, just a second. Okay, problem with my mouse. Okay. So guys, yeah. So naturally, these two terminals, 1A and 1B, are internally connected. Okay, naturally, uh, and the terminals 1B and 2B. I mean, the terminals that have different numbers are naturally open, in the sense not connected. Now, let's just connect the push button in series. We'll just take one end of the resistor, and we'll just connect it across terminal 2B, and from terminal 1B. We'll just complete the circuit by connecting it to the ground. Okay, so yeah. So let me just click on simulation, start simulation. So guys, now the circuit is complete. Now as you can see that I haven't pressed the button yet. The circuit is closed. Now whenever I click on the push button, the LED glows. So you can even see the pressing action over here. When the button is released, you can see a shadow. But when the button is pressed, you can't see the shadow. Okay, that's just a one good feature of Tinkercad, and that is why many people use it. So so yes, this is actually a basic connection of a push button. If you are still confused, well, always just remember that the terminals that are different, that is, see, 1B and 2. So 1 and 2, these two terminals are different. So these two are naturally open in the sense the switch, I mean, you can't, okay, sorry. So these two terminals are naturally open, okay? So in the sense, even if you connect it, the current doesn't pass. So you need to push the button, okay? So this is a simple demonstration of a push buttons. I hope it's clear with everyone. Does anyone of you have any doubt? Or did I go too fast? Okay, cool. I think everyone is clear. So yes, this is how to actually connect a push button. In fact, like we studied, there is also a slide switch, right? So I think you can find a slide switch in Tinkercad also. So let me just show you that. Just type in slide switch. So yeah. Before making the connection, let me just remove the existing connections. Yeah, I'll just select the slide switch and okay, let me just place it somewhere over here. Okay, so guys, slide switch is actually a three-terminal device. Guys, one common thing about push buttons and a slide switch is that you can simultaneously control two circuits. In the sense, where was it? Yeah, see, if you look at the diagram over here, okay, so when the push button is pressed, well, these two terminals got connected, okay. In the sense, you can simultaneously control two circuits. So the same way, using slide switch also, you can actually control two circuits. How? See, when the slide switch is like this on the left side, these two pins are connected naturally, okay. When I move it, okay, when I start simulation, when I click on start simulation, I can just move the switch over here. So when I do that, these two terminals will get connected, okay. Now let me just show how that works. So I'll just connect this switch in series with this circuit. Okay, let me just move it here so that it'll be convenient. So what I'll do is, uh, okay, let's just keep the ground terminal as it is, because we have connected this part of the circuit over here. Now what we'll do is that we'll just take the positive terminal. We'll just connect the switch in the positive terminals path. Okay. So what we'll do is we'll take one end of the uh, battery terminal. We'll just connect it over this side. Just mark it red. Now guys, there are three terminals, right? There is terminal 1, terminal 2, and in between there's a common terminal. Now, this common terminal, well, usually in electronics projects, what happens is when you just go over on YouTube or Google, so usually the word common depicts ground, okay? But here in this switch, common is basically just to help you understand the configuration, okay? So what we'll do is we'll just connect this common terminal to complete the circuit. In the sense, we'll just take okay, these are well, since all the pins are connected, I'm just taking the connection from here, okay. So I'll just connect this to the positive terminal. So guys, what I just did is that previously directly it was connected, no, the positive terminal. I just introduced a switch in between and connected it to the common and one more terminal, okay. Now let me just start the simulation. Guys, these are all kind of a very ground level basic stuff. If you have already known, I would suggest you to learn more about types of switches, etc. So yes, I clicked on start simulation. As you can see, even if I press the push button, the circuit is open, right? Now let me just click on the slide switch. So yes, now the circuit is closed. So now, as you can see, that the circuit is working. So guys, this is how you actually connect a slide switch. I think this was very much easy for you all to understand. Simultaneously, you can even take this terminal and connect one more LED, and maybe you can make it something like even when this circuit is off, the other circuit may be on, vice versa, something like that. You can make it. Okay. So yes, this was a demonstration of push button and slide switches. Uh, Now let's just move to the next topic. So here is one important electronic component. It's called light dependent resistor. It's also called as photoresistor. Okay. Now, if we go back to the project section, you might have heard this project, right? Automatic street lights. So basically, that project, what you need to do is that whenever there is sunlight, I mean, the light does not glow. Whenever, as soon as it starts to turn dark, then the light glows, right? So that's what happens in a automatic street lamp. So this is an important component. In fact, this is one of the brilliant inventions that people ever did in the field of making use of properties of materials, okay, using the resistance of materials. So what happens in a light dependent resistor or even LDR is the resistance of a photoresistor decreases with increase in the light intensity. So what happens is that uh, the light can be any light, okay, because it really does not matter where the photons are coming from. It can be even sunlight, the solar that is sunlight, or even it can be a torch. Now, how this device works is, let's say if you have connected this a photoresistor in series in a circuit, and in one terminal you connect it to a voltage source. Now, whenever there's no incident light, okay, whenever there's no incident light, so what did we just study? The resistance decrease with increase in intensity, okay. So whenever there is no light, then the resistance will be high, okay. Now, I don't want to say because the intensity is zero, the resistance is infinity. No, resistance can't be infinity because all practical devices have limitations. So, but the resistance will be quite high. In fact, it will be on its the resistance will be maximum, okay. So when there is no light, so if you have connected it to a voltage source, whenever there is no light, then obviously if the resistance is high, then there won't be any output voltage, no. So you won't get any output voltage. But if you actually shine some light on the LDR, what happens is that uh, like the more brighter the light is, the resistance decreases. So what happens when you have connected to a voltage source, you will get a output voltage. So we'll be actually let's do a quick demonstration of this in Tinkercad. Okay. Yeah, I'll just keep this. I'll just build a fresh circuit. Okay. So I'll just take one more breadboard. Uh, I'll take an LED. Okay. We'll just connect it with an LED. Okay. And why are we taking LED every time? Like Ruchita said, guys. See, in computer science, what's the most basic thing you do? You print "Hello World," right? In electronics, the most basic thing you can do is lighting up an LED or even blinking it. Okay. So that's why we are experimenting everything with an LED. Okay, I'll just use the resistance. Okay, you can even search LDR or okay, I think I need to search photoresistor. Oh, yeah, photoresistor. So guys, at this point of time, there might be a doubt that is arise, right? See, this is a photoresistor. There's already a resistance. Then why are we connecting this resistance again? Guys, let's say if I let's say if I shine a light that is way too brighter, such that the resistance of this component almost reaches to zero. So like Ruchita said, LED have their own current rating, right? So if we shine a very bright light, we don't want the resistance to be as low in order to burn this LED. So always whenever we are working with LED, we always have this resistor to save its life, okay? Just in case. So yes, what we'll do now is we'll just connect this photoresistor in series with this circuit. Let me just take a battery. Okay. Yeah, just change the color to black. Okay. So yeah, we'll do the same connections that we did earlier on. We'll just connect this LED, the anode to the positive side. And since this is series, I'll connect one end of the resistor to the one end of the photoresistor. And guys, just like a normal resistor, a photoresistor also does not have any fixed terminals like an LED. Okay, you can just make it ulta and connect however you want. So yeah, I'll just take one more leg and connect it to the anode. Sorry, the ground. Sorry. So yeah, now I have connected this in series. Now let's see. Well, just click on start simulation. So guys, in Tinkercad, what happens is whether it is a photoresistor or you even get a lot of sensors in Tinkercad, okay, like this motion sensor. So whenever you are working with sensors on any input device in general in Tinkercad, what you need to do is that in order to simulate a real world input, you just need to click on the component. See, when I click on this component, I can adjust the sun's brightness. Okay, let me just see. Now there is no sunlight, right? Since there is no sunlight, the resistance is uh, high enough. Okay, so that's why you don't see, but still a small part of light, the LED is actually lighting up because like I said, these are practical devices. Okay, now as soon as I increase the intensity of the light, you can see that the LED is glowing, right? And if I decrease back the intensity, we'll see that the light starts to dim again. So what's happening here is that as soon as the brightness is increasing, the intensity as the intensity of the incident light increases, what's happening is the resistance decreases. So in turn, the voltage is actually increasing. So yes, that is the reason. So maybe at this point you're confused, right? Because just because I said that we use this in the automatic street lights, maybe you get this question. Okay, wait, if there is sunlight, then it has switched on. Then what's the point of using this, right? Now, guys, these are basic components. Okay, now this is the natural function of a photoresistor. Now, if you want to use it in a project like an automatic street lamp, then you need to use it along with an inverter circuit. Okay, so that's actually a little next step, complicated stuff. Okay, not a complicated. You can definitely learn that, but it's not as basic as that. Okay, so because we just need an inverted configuration, right? What I mean is we just want whatever is happening now, we want it to happen ulta. Okay, if in case of automatic street lights. So that is the research components like resistor, potentiometer, light dependent resistor. So and also there are other electronic components like capacitors, transistors, right? You might have studied it in your 10th or 12th. Now, see, in electronics, just like how we classified the sensors, right, as analog, digital. See, everything in electronics can be properly classified. Okay. Now, one such classification of components that you should know is uh, active and passive components. Okay. Now, the elements that the basic electronic components, right, we can divide those two into active or passive. Now, what is that active and passive? Now, the elements which are capable of providing or delivering energy to the circuit are called active components. Okay. Now, what are passive components? They are the ones that do not require any external source for operation, and they're also capable of storing energy. Okay, in the form of voltage or current. Now, now, active is the one that can provide circuit that depends on a voltage to function. Okay. Now, here is a chart that actually shows you which are all the active and passive components. As you can see that all the components that we are discussing right now are passive components, right? Now, yeah, the resistor, thermistor, capacitor. Uh, well, thermistor is, I'm just saying this because, see, basically what a thermistor is that it's a variable resistor that whose resistance varies in according to the heat, okay, according to the temperature. Now, it's just like an LDR, but it make use of heat energy rather than light energy, okay. Now, all of the active devices are the transistor, diode, even LED is an active component. Now, we also have integrated circuits, 7-segment display, battery. So these are all active components. Okay. Before moving to the next part, and also one important thing that you guys should know is that Okay, we did not include that in the slide, but so let me just show you how a motor is connected. Okay, see, because in all the projects, like let's say an automatic, Bluetooth controlled car and stuff, the connection of motors are uh, way much important. Okay, let me just build one more circuit. Now, if you are someone from like PCME or even in your 10th standard physics, you might have studied the basics of how a motor works, right? Can anyone say on what principle a motor works on? Anyone? Okay. Okay. So basically, how a motor works is that it's based on a rule called Fleming's left-hand rule. Now, I don't want to make things complicated now, but the basic principle is that if there's a current carrying conductor, okay, in a magnetic field, then it experiences a force. Okay, that's the basic principle behind working of motors. I would definitely encourage you to go over the internet and study its working. It's really interesting. Uh, okay. Guys, the motor connections are very simple. Okay, you don't even require a resistor like an LED. Okay, because a motor is it has way more current rating than an LED. Okay, in fact, it requires way more current. Okay, maybe if you have like let's say if you went to Google and search Bluetooth controlled car, then maybe you would have heard this word called motor driver, right? I think we even saw it in our a block diagram of a remote controlled car, right? So in between in our system, we saw this component called motor driver. Now, what is this motor driver and why do we need it? Uh, Guys, I told you, right, we don't need any resistance to connect in between a motor because it has a higher current rating. And also that is one disadvantage, okay? I mean, because most of the microcontrollers, I mean, that we use in embedded systems can't, give an output of so much current, okay? So that is the reason we use motor drivers, okay? Now I would definitely encourage you to again go and read more about that. Now motor connections are really simple, okay? I think many of you already know this, but I'm still, I mean, for those who are from PCMB background, and if you are a little confused, watch this. So basically, motor has two terminals, right? Now, what happens is that you can actually change the direction of rotation of this motor based on the pin connections, okay? Now, well, now here you can see that there is a red color pin, okay? So the reason they have given the pin is just because to make sure that it is rotating clockwise, okay? Okay, let me just connect it directly and show it to you. So I just connect the positive to the positive, and I just connect the negative terminal to the negative. Okay? Let's change the color. I click on start simulation. You can see that the motor is rotating clockwise, right? Now, okay, one advantage of using Tinkercad is that you can monitor the speed of rotation. Okay, there it's showing 17,568, but this is not the exact speed that you would get if you are using a normal DC motor, the gear motors. Okay, now, yeah, this is as you can see that it's rotating clockwise. Okay, if it's difficult for your eyes to catch, just see this number. Okay, now there is no, it's an unsigned number, right? Now 17,000 is not signed. Now just look what happens when I actually invert the connection. What I'll do is I'll just connect this one here, and I'll just connect this positive to here. Okay. What I've done is I've just interchanged the connection. Now if you click on start simulation, you can see that the motor is rotating anti-clockwise. As you can see, the number is signed now, minus 17,000 for the opposite direction. Okay. So yes, this is just for you to get familiar with motors. Okay. Now, I think just a second. Okay, guys. Till now, you guys have learned how to connect LEDs with resistors, how to connect a potentiometer, etc. Right? So now what we'll do is this is just a handwritten circuit of uh, a motor connected with a potentiometer and an LED. So guys, basically a potentiometer, the best application is your fan regulator. Okay, in your homes, if you see the fan regulator, the continuous one is an example. It works something similar like a potentiometer. Okay, now, here is a simple circuit. It is a handwritten circuit of a simple motor configuration using a potentiometer. Now, this diagram, if you are not familiar, let me just take you back. Yeah. So here you can see that this is actually a standard symbol for a potentiometer. Like Ruchita said, we have three terminals in a potentiometer, right? The middle one, the wiper terminal, actually is indicated by an arrow. Okay, an arrow. So in this diagram, there's an arrow. That means we'll be connecting one end of the motor to the wiper. Okay, you don't need to worry about the this terminal right here because we are leaving it open anyway. So yes, we'll be building this circuit now. It's like putting direct theory into practical. Guys, in the meantime, we encourage everyone. I mean, I mean, for those who have logged into the session using your laptop, we'll wait for like 2 minutes. You guys can open Tinkercad and you can just try out this circuit now. We'll be building it along. If you don't have access to laptop, you can just follow along. So yeah, we'll wait for 2 minutes, guys. You can just go. Okay, let me just just type out tinkercad.com in the URL section, and you'll be taken to a home page. Type tinkercad.com. Okay, now since I have already logged in, I'm being redirected to my home page. Okay, so as soon as you type the website name, guys, you can actually log in with using your Google account itself. So as soon as you log in, you'll be taken to this page. Then after this, like uh, we showed you earlier, you need to go to circuits and click on create new circuit. Okay, guys, we'll wait for like 2 minutes. So those who are watching the session on laptop, we would really recommend you to go to Tinkercad and just try out this circuit once. We'll just wait for 2 minutes. Okay. In the meanwhile, if you guys have any doubts or queries, you can put it on the chat box, or even if you can unmute and ask your question.
You can try the circuit along with us while we are doing. So you just log into, open the Tinkercad, create an account if you don't have one, and we can do it together. So when you guys try it once, when you get the feeling of doing it, maybe you'll go back home and you'll go back and do try other circuits as well.
So yeah, we'll just wait for 2 minutes. Uh, okay, let me just put the link of the circuit diagram in the chat box. Okay. Uh, Yeah, the link to the circuit diagram, it has been put up in the chat box. You can, open the tab simultaneously as you open the Tinkercad. Guys, just give out a quick confirmation if you're, able to log in and, see this, open the uh, dashboard. Okay.
we'll try the circuit at around 6:50. So people who couldn't do, try creating an account for yourself, guys. It's fine if you guys do not have your laptops right now with you. You can just follow and maybe try the circuit later and try other circuits later.
Okay, so guys, let me just explain you this circuit. Okay, so basically, we have a battery and a potentiometer that is connected to the motor, and we have just created a parallel connection of an LED with the motor. Okay. Now this is actually a standard schematic symbol for an LED. Okay. Uh, I mean, if you remove the arrows, then you would get the symbol of a diode. Since it's a light emitting diode, it's represented with the normal diode symbol along with the arrow. So yeah, we'll build the circuit from scratch. Take one breadboard. We'll take a battery. And guys, whenever you're building circuits, okay, it's always advisable to write a schematic diagram on a piece of paper. Okay. So yeah, let's connect the motor. So okay, let's just place all the components on our breadboard right now and later make the connections, because directly making connections sometimes it can be confusing. Okay. Guys, you can just do along with me, okay? If you have Tinkercad open, you don't need to like follow. Okay, I'm placing motor over here, so it's nothing like even you have to place it over here itself. Okay, it's just that the connections have to be same. Okay, so just follow along whatever I'm doing. So yeah, LED. So I'm connecting a resistor, and what else? Potentiometer. Okay, I have a potentiometer here. I will connect it here. So yeah, I have placed all my components on the breadboard right now. So let me just start making the connections. Uh, so guys, since we are using more components now, okay, just a second, let me just connect the battery. Guys, what I'll do is I'll power up this column as well. So since this column has already powered up, I just take a wire and just drag it along to this column. Make it red, and just take this and I'll just make it black. Yeah. Now let's look at the circuit. Now we can see that one end of the pot. I mean, okay, one terminal of the pot is connected to the negative terminal of the battery. Okay, let's just do that. Just place the pot a little closer. Now, one end of the pot is connected to the negative terminal of the battery. Okay, so I'll just take this terminal. If I connect the first two terminals, if I move it clockwise, what happens is the resistance increases, right, and the speed decreases. So what I'll do is I'll just connect these two terminals so that what we want is because what is our final product? What is our final prototype? You know, if we increase the potentiometer, the speed should increase, right? So we'll just connect these two terminals over here. So yeah, this terminal I'll just take and connect to the ground. So yeah, and this terminal, the middle one, I'll be connecting to the motor. I'll just a second. Yeah. So yeah, I'll just take the wiper end and I'll just connect it to the negative terminal. Okay. Yeah. So next, I need to connect the positive terminal of the motor to the positive terminal of the battery. The positive terminal of the motor is here. I'll just take a connection and I'll just connect it to the. Now what we need to do is that uh, the resistor and the LED, we are actually we need to connect it in parallel with the motor. Okay. Now how do we do that? Uh, that's why we have mentioned the terminals here. Well, K is actually cathode, okay, not C, the usual representation, because if you go like 100 years, you know, when electron was discovered, it was written ELE KTRON, okay. So from that time, you know, they're following this configuration. That's why cathode is represented by K. So okay, sorry, where was I? Yeah, the cathode I need to well, cathode is the negative terminal, okay. The negative terminal I need to connect it to the negative of the motor. So yeah, that is the reason we powered up the below two rails also, so that we can take connection from here, you know, instead of, you know, drawing a long wire from the above. Uh, yeah, uh, the negative terminal will connect to the motor. Okay, I think we have connected the cathode with the resistor here. Okay, we have connected it. Okay, I'll just move the resistor over here. Okay, I'll just move the resistor over here. Just move the resistor to this side. Okay, so yeah, the cathode I need to connect to the negative terminal of the motor. Okay, so here is the cathode. Uh, Let me just take a connection from here, and I'll connect it to the negative terminal of the motor. Okay, let me just mark. Okay, yeah. So now let's just complete the circuit. Let's just take the one end of the resistor and connect it to the positive terminal of the motor. So here is the terminal, resistance terminal. Uh, So guys, be careful. We don't want to connect it here because this terminal has been connected to the ground, right? Uh, okay, never mind. I'll just put it directly. Okay. But guys, you make sure that you guys are, you know, doing it a neat way. Okay. Don't just put it in real. Okay. Because in real, when you're doing building a physical circuit, you know, don't just connect it like this. They'll mess up the circuit. So yeah, I think we have done our connections now. So let me just click on start simulation. Okay, just a second. Sorry, I think we have missed a connection somewhere. Mm, okay, the positive. Okay, the pot. Okay, sorry. Okay, the pot one is connected to the negative. Connected to the okay, the wiper terminal connected to the negative end of the motor. Remove the LED configuration and let's just see if the motor is working or not. Okay, just remove the LEDs. Okay, thank God it did not work on the first attempt. Okay, so I can tell you how to actually. Potentiometer is actually in series with the motor. So we'll just connect it in series. Uh, we'll just take this one end, just connect it to here. Hmm, positive rail. Yeah. Okay. Where are we going wrong? Okay. Guys, since there's no, exact terminals for potentiometer, what we'll just do is, instead of connecting it to the ground, we'll do one thing. We'll just connect it to the positive terminal. I need to connect it to the ground. Okay. So this rail is grounded, so I'll just making the connection. Oh, here we actually went wrong. We had to just a second. Okay, I think the polarity has to be interchanged in this diagram. Let's just check if the circuit actually works. Ta-da! Doesn't work. Just a second, guys. Let me just change the terminals and connect it and see once. Okay. Okay. What I'll do is let me just connect the positive end to one side of the motor, and I'll just connect the one more terminal to the wiper of the pot, the middle terminal, and let me just connect the uh, next terminal to the negative end of the battery. Okay, we already have a negative powered rail here, so I'll just connect it here. Yes, I think there's some issue, guys. Just a second. Let me just diagnose it quick and get back. Until then, if you have any queries, feel free to put it in the chat box. Okay, I'll be back. Oh, okay, yes. Here's what had actually happened. Okay, I hadn't, uh, what I had done earlier is, that's the reason why everyone has got and I did not, because I had just pushed the battery inside this breadboard. Okay, so that's why it did not work. So I did not make proper battery connection. So just I'll just keep the entire configuration same and I'll just connect the battery properly. Okay. So yeah, now it should work. As you can see that the motor is rotating as I change the dial. You can see that the speed of the motor varies as I increase or decrease the dial. Yeah, this is the highest and this is the lowest. Okay. So now that our motor, okay, I think last time the LED one should also have worked. Okay, I should have checked my battery configuration. So let's just okay, this is correct actually. Okay, I'm happy that many of you actually got it. My bad, I did this mistake. So what we'll do now is we'll just connect the same with an LED and resistor, and I'll just show you. Okay, you guys, okay, you guys tried this also. It worked. Okay, what I'll do now is let me just connect this with the LED. I'll connect a resistor. Yeah. So now, since it's a parallel circuit, I'll be connecting this uh, directly in parallel with the motor. Okay, just a second. Let me just move it a little closer to the motor. Okay. Yeah. So, so what I'll do now is I'll connect the positive end of the LED to the positive terminal of the motor. Okay, because it's a parallel connection. So, second I'll move it. Okay, this is not the way of doing. Okay, I mean, let me just do it neatly. I'll just place it wherever it was earlier. So what I'll do is I'll connect the positive terminal of the LED to the positive terminal of the motor. You can actually arrange these components neatly, okay, and do it all together. Like you can keep it side to side, okay. So don't make it messed up like this. So yeah, since it's a parallel connection, I'll be connecting the other end of the light. The other end of the resistor to the negative of the motor. So let me just connect it directly. Okay. Okay. Cool. So let's just start simulation. Oh, okay. Eureka. So yeah, it's working. So, so yes, as you can see that when I'm increasing or decreasing the knob, you can see that both the speed of the motor as well as the brightness of the LED changes accordingly. Okay, now I'll decrease both or I can increase both. So, so it's basically this potentiometer with the motor is the similar configuration that you see in your household fan regulators. So yeah, we just added an LED to uh, so that the circuit becomes more interesting. Okay, so in fact if you look at other electronic circuits, a resistor within an LED is always connected in parallel. Okay, and if you guys are wondering what would happen if I just connect this motor and this uh, node in series. Okay, in that case what would happen is, you guys know what happens in a series circuit, right? The voltage gets divided. So in that, what would happen is the motor would not reach its maximum speed. Okay. So, so yeah, guys. So yeah, this is all I wanted to show you from that time. Uh, so I hope many of you guys have actually tried along with us, and we are happy that many of you actually got it also. So until now, whatever has been presented, do you guys have any doubts? No doubts. Okay. Okay. Cool. So yes, guys, that's all actually about Tinkercad. If you actually scroll down, there are so many components that you can use it in Tinkercad. Be it the gear motor itself, or even the transistors, diodes, and all kinds of sensors. Okay. In fact, you even get a lot of ICs also. Okay, not only basic components, you also get complex integrated circuits, etc. You can always search it over here, and you can just start tinkering. Okay. Uh, Now, see, whenever you're building projects, if you just go to Google and search, let's say Bluetooth controlled car or whatever. So I'm sure many of you have heard this word Arduino, right? So basically, like I said, in an embedded system, a microcontroller is like the brain, okay, in an embedded system. So Arduino is one of the platform, okay. It's based on Atmel 80 mega microcontroller. So basically, it's a platform where you can build your prototypes more quickly, okay. Uh, Basically, why this Arduino was created is, let's say if you are a computer science student who knows programming, but you have a project idea, you have a product idea, and if you want to work on that product, but let's say you don't know much electronics, and let's say you did not even find a person who knows a lot of electronics, okay. So then what you do is you just go and buy one Arduino. So what this does is, this is basically an open source electronics platform. Okay, it's based on easy to use hardware and software. So basically, if you know how to program, let's say C language, then you could easily connect it to your laptop and program it, to behave however it want. Now, basically, it is an open source hardware. Anyone can get the details of its design and modify it, and you can even make your own Arduino, okay, because it's open source. Maybe you have heard this word open source, okay. Now, why Arduino? Now, in our first slide, we saw, right, the journey of a product. So basically, you will have your idea, and you'll build a prototype, then you get the final product. Now, before building circuit, PCB, and firmware, building your circuit with Arduino is one of the simplest and the easiest things in order to test the functionality of your circuit. Okay. Now it's more useful for rapid prototyping than developing actual production systems. Okay, you can easily get one, or you can, in fact, even Tinkercad has Arduino. Okay, I think we might need we need to connect a different workshop, in order to explain more about Arduino, because there's so much to learn about it. So, so yes, that's it about Arduino actually. Now I think we almost reached the end of the workshop. Now let me just uh, let Ruchita will continue this workshop ahead. Over to you, Ruchita.
Yes. Guys, will not take much more time. I know it's already 2 hours past. Just another 5-10 minutes. That's it. Okay. Can you guys see my screen?
Yeah.
Yeah. So guys, from the time you guys have come into college, every time you come across PES or something, we always keep telling you about Voltop, Voltop, Voltop every single time. So we are telling it to you so much because it has a lot and lot of importance. As I told you in the starting, what is expected from an engineer. There was these 2 points. One was creative thinking, and the other one was problem solving skills. So you just don't learn those stuff in the, you have to keep solving circuits problems or something, and that's where Voltov really helps you, like, when our seniors, when we were in first years, when we joined, when our seniors, I still remember Prithvi, Anna, Snehaka, all these people, when they came and told us, we were like, ah, chal hoga, we'll do it later and all. But then when after here, now in third year, we actually understood what they meant back then. So we again, the history repeats always. We are telling you how important this is. Don't ignore it. Understand the importance, and you know, even if the circuit is wrong, it's fine. Just give it a try. So this was just one of the question that we had given in the month of November, where we asked the participants to build an alert system that would detect any obstacle or enemy ship in around a submarine, around the submarine. So when the enemy ship or something enters into the green zone, so it had to tell the people in the submarine that there is some enemy ship coming inside. So as the ship comes closer, it has to tell the submarine that the ship is coming closer by, and it is at this distance in this direction. And when it enters the red zone, it should raise an alarm that it is in the it's like very close, or we have to do something about it. So it was just a basic alarm system, that alert system, that we asked the participants to build. So the main component here is an ultrasonic sensor. Actually, we expected the participants to keep the ultrasonic sensor in all the four areas: left, right, front, and back. But I think most of them didn't get that. See, you just don't solve it. You just don't see what is there in the question. You see generally, right? Uh, Enemy ships do not come in one direction. They come in all four directions, or any direction for that matter. That was one thing where people didn't the participants actually forgot that. See, that's why if you keep solving problems, you'll get to know where you have to put what. And yeah, this is actually this month's Voltop statement, because we had juniors, newcomers in the college, so we just thought of giving a very basic one which didn't have any microcontroller involved. So this is a very basic question. I think it is like it is in trend. Hand sanitizer dispenser is just in trend. It's like everywhere around. So I think, guys, you all can give this a try. There is still time for this month's Voltop to end. You have 2 more days. You can just go on YouTube, search for a few links where to create a hand sanitizer dispenser. Now that you know how to use a Tinkercad, like how to make all these connections on a breadboard, everything, I think you all can give it a try and submit the solution. See, it'll really help you, and you'll enjoy doing the circuit as well. So again, you'll find the question in IEEE UC PES Telegram account. If you haven't joined in there, you can join the Telegram account. You'll find the link of Telegram account in our Insta page as well. So just go there, get the question, go to YouTube, search for the videos, and try solving. Get a simple circuit and try solving it, and you can submit the solution to either me or Srinidhi through WhatsApp. Again, it has no microcontroller involved, so it'll be easy for you guys to solve it. Okay, so finally, again, see, this is a very basic workshop that we wanted you guys to understand. Okay, anyone can start off electronics. You do not need to have, it's not a big rocket science or something. Yes, towards the end it's a rocket science, all of that, but in the starting it's not that. You just have to start off with things. So here we just learned of interfacing the basic components. The next step is you to learn, you should learn an Arduino, and then a Raspberry Pi, and finally IoT. So it's like step by process. So I hope this was helpful for you guys. And yeah, it was lengthy, but the learning takes time. So I hope you guys are happy with what with the workshop that we did today. And I hope to some extent, maybe the doubts that you had, if you want to take core or IT or something, is a bit clear, because you can definitely give try for the first years and second years. You guys still have a lot of time. You can you can give this still a try and start off from scratch. No time is wrong actually. The day you start learning is the you know y- you just go ahead from that time. It's still not late for anything. Thank you guys.
And guys, if you have any queries, doubts, you can always write to us at ieeuvc+@gmail.com. I mean, if you guys have doubts now, you can actually put it in the chat box, or even you can unmute and ask. Or if you don't want to ask here, you can always write to us at ieeuvc+@gmail.com. I'll just put the mail ID in the chat box. Even you can contact us through Instagram. You can even DM us on Instagram. I hope the session was informative, guys. And also, you guys even witnessed, how a project actually fails. I mean, just because of a small mistake of a battery, the circuit did not work, right? So this is what usually these type of small minor mistakes happen. But the reason why you should learn, practical electronics right from basic components is because of this reason. You should be able to diagnose the project, at a much, what do you say, closer level,
Early
right?
stage. Yeah.
Yeah, true. So yeah, so whenever you don't get, the circuit, if it doesn't work, make sure that you verify it with your circuit diagram. And so that is the reason you need to know a little bit of theory also. You can't directly jump into practicals.
So yeah, we have finally come to the end of today's workshop, and we hope it was really informative, and we hope we were able to clear your doubts of taking either core or IT. We love to see you guys. Every month we'll be releasing, so every month we hope we get a lot of submissions from you all. And once again, thank you to each and every one of you for attending today's workshop and making it a success. Thank you, guys.
Yes. And one more thing, we were really excited for the workshop, so we forgot to introduce ourselves. So I'm Srinidhi from third year electronics, and we have
And
Ruchika.
I'm Ruchita from third year electronics.
So yeah, if you guys have any doubts, you can even meet us in college and talk to us about electronics. Okay.
Yeah, you can
Yeah.
not just about electronics; it can be about anything.
True.
Yeah. So you guys can talk to us anytime you find us in college, or you can DM us as well.
So yeah, if anyone wants to say something, or if you have any queries or doubts, guys, if you don't have any doubts, you can leave the meeting.